Okay, now we will go through the real-life problems applications of the Calculus BC questions. We can look at some problems like optimizing the design of a container, the volume of some certain objects in real life, and using calculus we can minimize the surface areas for some given volume, which has applications in manufacturing and design. The TI-nspire makes these calculations straightforward. By inputting the necessary equations and constraints, we can quickly find the optimal dimensions. Now we will look at a problem from the 2023 Calculus BC test, Section 2, Part A, which is a part that requires the graphing calculator to be used. The time given for this part is 30 minutes and we have 2 questions in total. And I will today focus on the question 1. In the first video, I will cover question A and B. So let's start now by looking at this question. A customer at a gas station is pumping the gasoline into the gas tank, and the rate of flow is modeled by Ft, which is a function here, and is measured in seconds since the pump began, and the units are gallons per second. So from this initial condition, we can infer that Ft is the rate of change of gallons at a given time t. So now we'll move on to the question A. So it asks us to interpret the meaning of a definite integral right here in the context of the problems. So apparently, if Ft is the rate of change of the gasoline pumped into the tank, then each definite integration would be the total amount of the gallons pumped into the tank over the given interval that is represented by this definite interval. So we can answer by it represents the total gallons of gas pumped to the tank between t equals 60 and t equals 135 seconds. But it has a second part to this question. We'd use a Wright-Riemann sum with 3 subintervals to approximate the value of this definite integral. So now we see down here, we use the definition of the Wright-Riemann sum, which is the interval length times the Wright's function value. We can easily find these values by looking at the table above. So we plot the product of these 3 subintervals together, and through here we can use some calculator. For example, the basic algebraic representation of this whole function right here. And through the use of such, we can calculate this value with ease. So after some calculations, it is gained that the total sum gained from the Riemann sum is 8.25. Now we move on to question B. So it asks us if there exists a value in the range of 60 and 120 that the derivative at this point equals 0. So now we can use one of the most important theorems that we encountered in our BC study, is that if f is differentiable, then f must be continuous over an interval. So it says that it is differentiable, so that it must be continuous. So from this, we can also learn an important fact, that if we take the average rate of change over this interval, and then we divide it by the interval length, then we can certainly get the average rate of change in this interval. Then that proves an important point. As long as the average rate of change over this interval equals to 0, then there must be a value in this interval such that the derivative at this interval equals 0, which corresponds to one of the theorems that we encountered in the BC study. So by conclusion of this problem, by the mean value theorem, there must exist a value c, for c is bigger than 60 and smaller than 120, such that the derivative at this point is equal to 0. The above equation is basically a mathematical representation of the mean value theorem. Now we move on to the question C. So now it gives us a new function of gt of this interval. And it asks us to find the average rate of change over this time interval. So it asks us to show the setup of our calculations. The rate of change, the average rate of change, can be actually easily obtained by dividing the actual definite integration over this interval by the interval length. How do we get that? So we first write out this function. We integrate the function gt over the interval of 0 to 150. And then we divided that value by 150, which is the length of this interval. So now we can get the average rate of flow of the gasoline in the gallons per second, which is 0.96 or 0.09. So at this part, we should note that we can actually use the calculator to solve this seemingly complex function. By inputting the value of gt directly into this definite integral, we can easily get the answer. Now we'll move on to question D. Now using the model defined in part C, we should find the values of the derivative of gt at t equals 140 and interpret the meaning of the answer in the context. So, what is the meaning first? The rate at which gasoline is flowing into the tank is decreasing at a rate of some gallons per second at t equals 150. We get this value by inputting this function into the calculator. How do we use it to solve it? We just press the derivative button and we input the function by itself. And then we input the specific point we want to differentiate it over. And now we can get this negative value, which means it's decreasing at a rate of 0.05 gallons per second, which is per second squared, at t equals 150 seconds. So that will be all for the first question of the 2023 free response questions. Thank you very much for watching. Okay, so now we will look at how do we use the TI-nspire CX2 calculator to specifically calculate for the questions shown in the video just now. So for the first problem that we actually need a complex calculation to do is this one. It's this calculation right here. We should calculate the average rate of change of gt over this interval of 0 to 150. So to do that, we need to input the exact function into our calculator. So how do we do that? First of all, we input 1 over 150 as the first term for our calculation. Now we will do that. And then we would encapsulate it in a parenthesis for the purpose of being accurate. And then we would multiply that by the definite integration. So how do we use that? So as you can see here, we have a catalog button. We just press it and open this menu. We choose this function right here, which means the definite integral. We input the lower and upper bound, which is from 0 and 150. And then we input the most important part, the function. For the function, we just input this direct thing over here. So that would take a while. And at the back of here, we input t after d to indicate the actual value that the independent variable we are integrating over, which is t. We can also alter this part with the notation that is more easily recognized, which we can do by selecting Control and restoring it like such. Now after this, we should form a good habit of checking back to our original function to make sure that it is absolutely the same for this integrand. After such, we will press Enter, which is also the Enter on our calculator, to get the value. Now you can see this value is very difficult and very complex. What we would do is we would perform this calculation again, but just at the end of this calculation, we will press Control and then press Enter, which is the approximated value. So this will be a lot easier to recognize. So now we can find the value is exactly right here as we get it. There are a little bit of errors here, but it is within the acceptable range. For the second question, in question D, we are required to find a derivative of the value of the derivative at a point on a function. Now this part is a bit more tricky, but it's also solvable. We would first press the menu button. Under Calculus, we would select derivative at a point. So we first change the variable to the same one in this question as t, and we set the value as 140, just as in the question. Now we just we look at the function right here, and we should be able to see that there is a function that we need to find the derivative for. So we just input it directly here within this parenthesis. So we just type t over 500 multiplied by cosine, just type cos and then another parenthesis. We type in, now we should note here that we should type in the same exact function without any difference, unless the result could be a little bit different. So now we just square the numerator and the denominator. Now after this, don't forget, we should get the specific value, so we press Control Enter, which then is the way we get the approximation value. Okay, now you can see minus 0.49, which is the exact value that we should be getting right here, as you can see. So for the final digit here, you can just approximate this one to minus 0.05, and that will be totally acceptable. So now that will be the specific process shown above for the two questions that require a complex usage of the calculator. I hope you find this video very useful and helpful for your study. Thank you very much for watching.